This is the 1-4 skills practice on the distributive property. It tells us to use the distributive property to rewrite each expression. And in problems 1 through 4, it's really just giving you practice to use the distributive property. It doesn't give you a whole lot of practical use of it. So what the distributive property says is that if you have something in parentheses being added or subtracted with a number on the outside that's being multiplied, you can distribute that number through to each of them inside. So the 4 gets multiplied by the 3. Keep the sign that's in between them, which in this case is a plus. And then the 4 also gets multiplied by the 5. So we have 4 times 3 is 12. And then 4 times 5 is 20. And you end up with 32. And when it says evaluate, it means come up with the answer. So when we've got the answer, we're done. So again, we take the 2 and we distribute it to each one. So it's 2 times 6 plus, because that's what's in between the 6 and the 10, 2 times 10. 2 times 6 is 12. 2 times 10 is 20, excuse me. And then 12 and 20 is 32. Five times 7 minus 5 times 4. 5 times 7 is 35. 5 times 4 is 20. 35 minus 20 is 15. And then in number 4, you can do it either way. You can multiply the 8 by this direction, or if it makes you uncomfortable to have it on the back side, you can just rewrite it. Because of the commutative property, the order when you're multiplying doesn't matter. So we can rewrite it and then just end up doing it the same way we've been doing it. So we'd have 8 times 6 is 48. And 8 times 2 is 16. So we end up with 32. And then this way we would have 6 times 8 minus 2 times 8. Again, we'd have 48 minus 16 and 32. It does not matter if you keep it this way or rewrite it this way. Doesn't matter. In the next couple of problems, we actually see how the distributive property is useful for doing mental math. The whole point of learning the distributive property is to be able to do the mental math very quickly. So we have 5 times 89. Now, I don't know right offhand what 5 times 89 is. I could do it the long way, but an easier way is to think of 89 in a different way. So 89 is close to 90, and things that end in 0 are a lot easier to deal with. So if I rewrite 89 to be 90 minus 1, this thing right here is still 89. It's the substitution property says if they're equal, I can put it in for it. Well, 90 minus 1 is equal to 89, so I can put 90 minus 1 in place of 89. And now I have a distributive property where the 5 is going to get multiplied by the 9 and by the negative 1. And the reason that this is handy is because I know what 5 times 90 is, and I know what 5 times 1 is. 5 times 90, I take 5 times 9, which is 45, and then I just add a 0 at the end, which is why it's handy when you're doing the distributive property to have things that end in 0. And then 5 times 1 is 5. Well, 450 minus 5 is just 445. In number 6, we have 9 and 99, and again, we want things that end in zeros. So I'm going to take the 99 and rewrite that as 100 minus 1. This is still 99, and all I've done is substituted it in for the other way of writing 99. So now I have 9 times 100 minus 9 times 1, So I have 9 times 1 is 9, 2 zeros after it, minus 9, which is 891. Number 7, I have 104. Well, again, I'm looking for things that end in zeros. So I'm going to turn that 104 into 100 plus 4. This equals 104. So I can write it in place for that. 15 times 100, well, 15 times 1, and then 15 times 4. So 15 times 1 is 15. And then I have 2 zeros to come after it. 15 times 4, well, 15 and 15 is 32. And 32 and 32 is 64. Or, excuse me, 60. 15 and 15 is 30. 30 and 30 is 60. So then I have 1,560 as my answer. Now in number 15, we're going to treat this mixed number like what it really means. And when you have a mixed number like that, you can actually write that as 2 plus 1/3. If it was a fraction or a decimal, you can always break it into the whole number and the fraction or decimal being added together. So now I have 15 times 2 and 15 times 1/3. Well, 15 times 2, I know that right off the bat. That's 30. And then 15 times 1/3. Whenever you see a fraction where the numerator, that top number is 1, being multiplied, what it really means is that you're dividing by the bottom number, the denominator. So if I'm taking 15 times 1/3, then that's the same thing as 15 divided by 3. So now I don't have to feel uncomfortable about that fraction, and I can just say 15 divided by 3 is 5. So my final answer is 35. Okay, now we're going to use the distributive property to rewrite each expression, and then it says to evaluate, but I'm pretty sure what they mean here is simplify, because they haven't given us what the variables equal, so we're just going to simplify the expressions. So just like in number 4, where we have the number at the back, we can always just rewrite it. If it makes you uncomfortable, put it in the front. So now I have 2 times a plus 2 times 7. And I don't need multiplication in between a number and a variable, so I'm just going to get rid of that symbol, and 2 times 4 is 14. Now I don't have any more like terms, and there's no more parentheses, so it's simplified. 7 times h minus 7 times 10. Again, I don't need the multiplication in between the number and the variable, and 7 times 10 is 70. I don't have any like terms or any parentheses. 3 times m plus 3 times n. And then the only cleaning up here is that I don't need the multiplication in between the number and the variable. Because they have different variables, they can't be combined, so that's as far as I can go. In number 12, we have more than 2 numbers in the parentheses, but all that means is you're doing multiplication 3 times. As many times as there are in the parentheses you're going to do. So you have 2 times x minus, keeping the symbols in between, 2 times y plus 2 times 1. So numbers next to variables, and then 2 times 1 is 2. I have all different variables, so they aren't like terms. That's as far as I can go to simplify it. In number 13 through 20, they're asking us to simplify the expressions, and if they already are simplified, we just write simplified. So in number 13, we have two things that have x. So they have the same variable with the same exponent on the variable. So to use the distributive property, we pretend that this was set up before as 2 plus, let's try and fix that, plus 8. And you can see, if I was to actually carry this out, that I would have x times 2 plus x times 8. And then we always put the numbers in front, so I have 2x plus 8x. Okay? So I haven't changed what I've done at all. I can get back to where I started. So the stuff in red is just to show you that I really haven't changed anything. So the reason that we do this is now we have 2 plus 8 in here, which we know is 10. So put the number in front of the variable. Our answer is 10x. In number 14, we're going to do something really similar. When we just see g with no number in front of it, there's an implied 1 in front of it. There's 1g there. So if I pull the g out front like I did with the x in the previous problem, then I'm left with 17 plus 1. Well, 17 plus 1 is 18, and then I put the 18 out front. And you should be able to check all of these with the distributive property to make sure that we've done it correctly. In number 15, we have x squared and x squared, so they're like terms. So I can pull that common factor out, which is x squared. And then I'm left with 2 plus 6. 2 plus 6 is 8. And then we put the number in front of the variable. In 16, we have a squared and a squared. We pull that a squared out front. And we're left with 7 minus 2. 7 minus 2 is 5. Oops, well, not that it matters that it's in parentheses, but we can put it out front now. And then we have 5a squared. In number 17, we have y squared and y without a squared. So these are not like terms. They can't be combined. So we say simplified. In number 18, we're going to use the distributive property several times. So the first one we're going to do is to distribute the 2 through. So we're going to have 2 times n plus 2 times 2n. And when you have numbers like this, you multiply them together as the coefficient, or the number in front of the variable. So I have 2n plus 4n. And now this is as if we started our problem over like we've been doing. So we have n and n as common factors. I can pull it out, and I'm left with 2 plus 4. 2 plus 4 is 6. So I have 6n. Same thing's going to happen in number 19. 4 times 2b minus 4 times b. So 4 times 2 is 8b minus 4b. I have common factors of b, so I can pull them out, and I'm left with 8 minus 4. 8 minus 4 is 4. So my final answer is 4b. And then in number 20, we have lots of q's, but we have to be very careful which ones are actually like terms. So I have q, q, and q, but only 2 of them match because they both have squareds. So I'm going to rewrite this so that those are next to each other. So I'm going to have my lone q out front, and then I'll say plus 3q squared minus q squared. So this is what I'm going to deal with the distributive property. They both have a q squared, so I'm going to pull that out front. This lone q stays by itself, and then I have q squared, and then I have 3 minus, well, there's not a number in front of this q here, so there must have been an implied 1, so 3 minus 1. 3 minus 1 is 2. And then the last step is just to write that number in front of the variable. And since I have q with no exponent and q with a squared, those are not common factors. They can't be simplified together. It's really important to keep track of the exponents on the variables because a like term has to match the letter and the exponent in order to be combined. All right, then number 21, we have to go back to section 1-1 where we write math expressions for verbal expressions. So the product means multiply of 9 and t squared. So I'm going to multiply 9 and t squared. Increased by means we're adding. The sum means we're adding 2 things. And those 2 things are the square of t, or t squared, and 2. So if we look at this, it says we're supposed to simplify and indicate the properties that we use. So I see 2 like terms. We have 9t squared and t squared. And since there's no number in front of the t squared here, there's an implied 1. So I can pull the t squared out front, and then I'm left with 9 plus 1. That 2 is still there. I haven't done anything to it. And that's by the distributive property. And then 9 plus 1 is 10. And that's just a substitution property. And then just rewriting 10 in front of the variable. And it is simplified. All right. Now, 3 times the sum of r and d squared. So I'm going to have r plus d squared, and I'm going to have 3 times that, which means I'm going to have parentheses around it, minus 2 times the sum, again, of r and d squared. So 2 times the sum of r and d squared. Now this one's a little bit funky looking, but if you look, this entire thing right here matches in both. So those are both common factors. So we can pull that entire thing out. So in parentheses we have r plus d squared, and what's left behind then is 3 minus 2. So we took this whole thing in each of these and treated it almost like the t squared up here. We just put it out front, and then what was left was the 2 and the 3 and the minus 2, and we put that over here. Well, 3 minus 2 is 1. And 1 times anything is itself. So we're just left with r plus d squared. And we're supposed to name the properties, so I guess I should go back and do that. So the first property here is the distributive property. And then the next one is a substitution. When we did 3 minus 2, we just substituted that was equal to 1. And the last one is the multiplicative identity, because anything times 1 is itself.